Hello again. Now I have some more interesting things to report on my diversions. Let's see, I used paint last time. It was my contention, if I recall, that I don't know if this is the best program to use, but anyway, about looking at it originally. The original example sort of started, you couldn't see much. And it wasn't that cylinder, it was, what was it, triangle. A funny colored triangle. Oh, not that line. Next line. Minus one. Right, so this line here, which is supposed to be green, and then 0, 1, like that. So the first one vertex was here, another was here, and another was here. And by, you don't have to give this one a second time. That whole thing altogether makes a triangle. And each of these corners had a different color and it had a funny color. And we were looking at it as something was happening. Now the Z plane comes out, let's say it comes out this way. By the Z axis. And it goes in like that. I'm going forever. Oh, I don't want to interfere. Okay. Now our position was y equals x equals. This goes way back to number 2, I think. Our view position it's been the same for all the examples. X, Y, Z. Okay, Z is minus 5 and Y is 3. Well, 3, currently 3 means down. I don't know how to draw it. How do I draw it? Okay, Y. X. Z. X equals 0, 1. If I could try and draw Z like that. Okay. Now, our Z is actually negative. We're minus 5. minus 5 along, you could go along the z-axis minus 5, and then go down. Yeah, that's it. That's the way to see it. So go minus 5 in this direction, text. Done with text. Get out of here. Oh. Okay, no, I like it. It's good. Keep it. Accept. Accept. Thank you. I just got to switch tools. Well, this thing is great. Every time I touch that, something good happens. So, now, at this point here is z equals minus 5. Now we're going to move a distance down or up. Right, no, down in the y direction. Okay. Line. And that distance is not red. Minus 3. Let's say. Doesn't look very good. Okay. Then I suppose that's minus 3. Text. Alright, now I can use this thing to place things where they should be. Oh, my 5's ruined. Make another one. Okay, that's that distance. And if I can move this one, that's that distance. And we're looking from here, the color green, that's our eye, and we're looking this way, towards the origin. Okay? Now, what would the z-axis appear to be doing in this case? Obviously, and we're upside down. Remember, we're upside down too. So our up direction is that way. So the z-axis would appear to go down, right? That line that I made would appear to be going down from our point of view, right? It's coming towards us but down. And that little triangle it's a tiny thing now in this thing, but I can draw it. That little triangle. Well, then they did the same trick on us with a a cylinder. You made a cylinder from y equals -1, excuse me, to 1, right? So in the new world, there's that cylinder that goes from -1 to 1, not very big. And but our viewpoint's the same, strangely enough. They didn't change that. You look at it, test 6 for the geometry thing, or get a point of view. Where is it? Yeah, I think it's the same. It's exactly the same here. Same numbers. Okay, but there's a small caveat. In the new world, we're still here at the green spot. How will we work it out? And we're staring at this thing, and surely the z-axis is the axis is, appears to be going down from our point of view. And so this thing also appears to be at an angle. Plus, our view is restricted. The distance from here to here it's not an integer number. It's 9 plus 25 square root of that. 35. I don't know. What's the square root of 34? Doesn't matter. That's the distance from here to here, but at a distance of 1, the plane perpendicular to this line of sight, a distance 1 away, and that's our viewpoint. Now, how I draw that is anyone's guess. How to draw that, because you gotta rotate this thing. The viewport, can't even move it. It's out here somewhere, and it's rotated so that it's, like that, and it's skewed, but I can't skew that thing. But you get the point, right? Tiny little viewport makes this thing look really big, because the viewport's what you expand the screen. No. I wanted to prove that this theory of the universe is true. So what I did, I said to myself, our z position, regardless of where we are in y, is -5, right? So anything that's less than that distance away, as long as it's above the z-axis, is that right? Above? Yeah, because we're looking upside down. Suppose we had an object. So above for us means actually below in this image, right? And so if you rotated that thing around, it would be below here and it could get into the viewport, as long as it was not more than 5 away. Hang on a second. Sorry about that. I'll probably cut out a bunch of stuff before this point, or there will have been a bunch of stuff cut out. So I'll just quickly review. This was the triangle. This is the cylinder situation. Both have the same property that our green point is where we are, and it's in the YZ plane. That's an important fact. Okay, so that plane is made up of that's Z and that's Y, so that's this plane. And if you don't believe me, think of it this way. Sorry. Write down an equation for the solution of which contains every point in the YZ plane. What is that equation? Somehow or other, took all my good flavors, threw them away. There it is. The reason for that then is because of the simple fact that x equals 0. That's the equation whose solution is all the points in the YZ plane, and that x is equal to 0 where we are, and the z, we're both in this direction from the z-axis. Our up orientation is increasing y values, so everything's upside down for us. The positions of things in our universe is in D3D, you specify the positions in the same way, but you won't, they won't appear where you place them if you happen to be looking at everything upside down. But anyway, so here is my contention. This distance is again -5. And well, let's hear what's whatever further on of this. All right. That's where we are. If I placed an object, any sort of object, on this side of the z-axis, but less than 5, so that at +4, I put something here. Okay, I'm going to put it, whatever it is. I chose a mirror because I thought that'd be kind of interesting. Try that. Put it here. If I put it here, like this, then it's close enough. It might, if I rotate around the y-axis, it might appear ahead of me, in front, not behind, but in front of the this view plane, which is only one distance away, right? So that means you wouldn't see the entire thing. You would see a bit of it, but that's okay. You can see that if this is below the line, then that's where it would be, or where it could end up visible. If I put something above this line, then it will never be able to see it because it's going to end up above the line on this side if we rotate around y, right? Well, we could see it from our view, and we're more likely to see it even when it's on this end, but not on this end. So I did that. I chose a mirror. I called it a mirror, and I happen to have a bunch of pictures of mirrors. And then now these are JPEGs. If I turn one into a PNG so it has alpha, and if you look at it in here, you'll see that there's a little space above and below, but it's pretty good. Now the mirror, I have to give it the right coordinates. And a size so that I can see it, right? One of the great things about direct 3D is it doesn't matter what the size of things are, right? Well, if I'm using this as a texture, what matters is the size of my triangles. So I don't need to resize any pictures. Now, what I did was I tried it two ways, and to show you. Okay, I've defined something called elevation. So it's going to be a 6x6 picture, right? Now the first point is at -3 in the x. So in x it's going from -3 to 3. And in y it's going from 0 to -6. Now -6 is the bad direction. That's this way. In real terms, I'm drawing it over my mirror. What's my distance? Oh, and 4 away, as I said, and 6x6. something like that, right? Now it's touching. It's actually touching the axis. It would be, except for the fact that the picture itself has some extra space, so it doesn't touch the axis exactly. And you're going to see the mirror in the distance here, and then I'm going to rotate around, and you'll see that we won't see it, even though we're 5 away and it's only 4 away, because it's above our view position. We're below the axis and it's above. But once it's far enough down, we won't see the whole thing. We'll see the bit of it that clips across the view plane. So we'll just run this. I'll show you the triangle strip. This is the point, by the way, that the help documentation outlived its usefulness. There aren't really any more examples, other than like super complicated things. Okay. So you see this strip? Now the UV coordinates 0, 0 corresponds to -3, 0. This is x, -3, 0 is, that's here. Recall again that it's upside down from our point of view. Okay, so -3, 0, then now y equals, texture y equals 1 when we get to y equals -6. So when we get to the top, that's 1. So it's going from 0 to 1, right? And since we're seeing things upside down, that means it should be right side up from our point of view. And so now I've gone from here to here, I think. Yeah, I just moved in y in my direction -6, and now I move to +3 in x, which is this point. Okay, and that corresponds to texture coordinate 1, right? And the x part is, whether it's flipped or not, it doesn't matter. And then down to finally 1, 1. So that's a little letter N there. No, yeah, that's right, a letter N. If I run this, now I'm going to have to pause it quickly. Okay, now there's the mirror. You can't see it at the moment, but it is there, just below the z-axis, below because everything's upside down. See? There it is. And I'm back to the beginning again. See, notice how the z-axis is coming up. We're 5 up, looking down, right? Because everything's upside down. When we turn this, you can see the angle where we are, right? We're way up high, looking down, and we're not going to see the mirror. Why? because the z-axis on this side is below us, and we simply can't see it because it's below, but it's still there. Now, that elevation is just a number I can change to, suppose I add 2 to all of these y values. Okay, so what does that do? Try to guess. Which way is it going to go, up or down? Yeah, as much time as it takes to compile it. A lot of time. Just think, well, I think of it this way. This is now intersecting the z-axis, right? Because we got points. We'll see soon. Okay, see? Now I've moved it up 2, and now it's intersecting the z-axis. The question is, are we going to see it? It looks like there's a chance we might see it. And we can just barely see it. See? It's just high enough. We're 5 away and it's 4 away. And moving it up 2 allowed us to see part of it. If I moved it up 1, let's say, I don't think, well, definitely I don't think we'll see it. That won't be high up enough. So that proves that to me anyway, that model of what's going on, the viewpoint and the viewport and the eye position and how that all works is exactly according to the docs. Or similar to that other thing I showed you. Here it is. It's quite low, and there's no way we're going to see that. No. This just can't see it. Okay. It took me a while to figure out how to get the alpha blending working. That's where, unfortunately, at one of the points where the help file breaks down on you. There's something wrong with it when you try to look things up. And you click on something like this. Like that one there. This. All it does is it gives you an error. So I had to guess. I knew that there's something about enable alpha blend, and I just did like a text search through the header files for like sequences using this render state. I still have the extra line I cut off there. It's an interesting thing about that. Yeah. Let me just copy that. Go back to where I want. Put it back. Now there's different ways to do alpha blending. There's source blend and source alpha. That's like the mirror has it. The mirror has alpha in it, like some transparency. And then there's something called desk blend. And for some reason, and I don't know what this one is, but I guess maybe it only does a single blend rather than repeating or something. But when you run with this option, look what you get. It's kind of cool. Everything becomes transparent a little bit. So, like, sometimes you turn off the culling if you want to see behind walls and make sure that everything inside is okay. But this works just as well. You can see inside. See? You can see the inside of the, like I can see part of this axis through this surface. And so you can get some pretty cool effects going with that. Like this already is a pretty cool thing, I think. Like, how cool is that? You know, especially with that mirror on the wall. If only, the reason I chose a mirror was because I know it might motivate me to try and figure out how to make this reflect. Now it's, yeah, see, now that mirror's got its own alpha, but I guess the scene itself has some alpha defined, does it? No, I don't know. I'll have to look at the help for that. But that's a pretty cool thing. Let's put it, oh, that's nice. Nice shot. Let's put it a little bit. Now we can move it beyond 5, and then we would never see it close up. We can only see it far away. Where is it? Sound for the vertices. Oh, I put everything in one property. CPP. How about we move it up to 3, and we could move it away or closer. Let's try it like this. No, I want to try this far away, 8. Just curious to see. So now it's pretty much now it's centered on the z-axis, but it's really far away, and we'll never see it. It's going to go behind our view at times, and so it'll be a larger range of angles where we'll see it because of its distance. There it is. Can't possibly see it. There it is. I also made these things, does this do it? No. Change direction randomly. Let that remain the same. Oh, let's get one axis. Okay, right? See, sometimes it can change direction. That's kind of cool. Where you go? There it is. It's jerky when it's even when it's rendering something that you can't see. Anyway, more fun to think about. Oh, this is so easy to do. You'd be surprised. Just try it. Download the thing and try playing with it.